Hey, everybody. Welcome.
Hi.
Yeah, welcome. This is the first episode of a four-part Learn Live series on building intelligent apps with AKS. Thank you to everybody that's joined the stream here today. I believe we're streaming in a couple different locations. I can't remember all the different locations, but we are here. We're live. My name is Paul Yu. I am a cloud native developer advocate here at Microsoft, and I'm joined by my colleague and friend, Ayobami. Ayo, do you want to introduce yourself real quick?
Sure. Hi, everyone. I'm a senior program manager at Microsoft for AKS and cloud native technologies.
Awesome. Thanks for that. We also have a live moderator with us, Michael from the Fast Track team. He's behind the scenes, he's manning the chat window, and he's answering questions live. So feel free, say hello in the chat, ask a question. Yeah, just fire your questions away. All right. So for this Learn Live, we're going to be doing a bunch of stuff, and we're going to be doing a bunch of stuff live. Okay. We actually encourage you all to actually follow along. We'll call it a code along. And for the next 4 weeks, we'll be going over through some docs and tutorials that are online. We also have some hands-on labs for you to do. So yeah, go ahead, crack open your web browser, navigate to this URL that you see here on the screen, or open your mobile device, take a snap of that QR code, and it'll take you right to the tutorial that we're going to be working through today. Okay. And again, live and interactive session. So feel free to say hello, drop a chat in the chat window, and somebody will get to your question. Okay.
And
If the
most
question,
importantly, don't forget to code along as well.
oh yeah. Code along. That's what we want, right? We're gonna, like I said, we're gonna do this just live and from scratch. So we'll see how it goes. Usually, the demo gods are good. And so yeah, we're gonna be testing them today.
Absolutely.
Cool. So what are we going to be doing today, IO? It's all about intelligent apps, right?
Yeah,
As
absolutely.
part of our campaign, the Fall for AI campaign, we want to just learn more about what makes an app truly intelligent, and from there we'll talk about taking on a cloud native strategy when adopting AI within your organization. And then we'll actually get our hands dirty. We'll deploy a OpenAI model on
That's the
Azure.
fun part.
Yeah. And then we will actually deploy an intelligent app on AKS. So should be fun. All right. IO, how much have you done with intelligent apps lately? Or how much have you heard about intelligent apps?
Honestly, it feels like that's all I hear these days, which is awesome because it's really exciting, right? It
Yeah.
honestly gives us the opportunity to put some really, really cool features in our apps. And these new technologies make it so much easier than ever
Yeah.
before.
Yeah. So yeah, I mean, the term, I mean, you've heard of ChatGPT, you've heard Copilot this for everything. We have a Copilot for everything now. Copilot for GitHub, Copilot for Windows, Copilot for, I mean, I can't even keep track of all the Copilots. But when we talk about what makes an app intelligent, what we're basically saying is your application is taking advantage of artificial intelligence to enhance or augment the user experience, right? Generative AI and foundation models has completely changed the game, right? So now we have users that interact with your applications just using plain language, right? Literally ask it a question, and that's the user interface, and that's the interaction that we get. And so we're starting to see this paradigm shift in the way that we think about using applications, but also the way we think about building applications, right? And so it's all about leveraging these large language models and building them into our application, right? But just because we're seeing this sort of paradigm shift in the way we build applications. That doesn't necessarily mean that you have to throw everything away and start from scratch, right?
Yep.
By taking a cloud native microservices approach to building these applications, you can easily enhance your existing applications. You can literally bolt on intelligent capabilities to your application. And that's what we're going to show you today. So I talked about microservices. At the end of the day, if you played around with ChatGPT, if you've seen some of their documentation for working with their APIs, what is the API? It's just a REST endpoint, right? Um, and so that inferencing endpoint is no different than what we've been doing for all these years, right? We've been building microservices for a number of years now, building microservices architecture, planning for deployment in the cloud and whatnot, right? And what platform comes to mind when you think about microservices and containers? Kubernetes,
AKS.
Kubernetes and AKS, right? Um, AKS, I'm pretty sure you've heard of that acronym. Hopefully, you've been playing with it a little bit. But if you have not, what Kubernetes or AKS is, it's basically an enterprise grade managed Kubernetes solution that we offer on the Azure platform. Okay. It's again, it's managed because running Kubernetes is kind of difficult, right? Unless you have a whole army that can do that for you, by all means. But on Azure, it's a managed service. It's actually built with all the best practices already built in. And there's multiple components that actually go into an AKS solution that allows you to operate it a little bit more effectively, right? When it comes to AKS and Azure in general, Azure actually gives you a full end-to-end cloud native development experience, right? And
Mhm.
so AKS actually integrates seamlessly with a whole bunch of other services within Azure, right? Things like Key Vault, Azure Storage. We have Microsoft Entra ID, which that's been renamed, right? IO.
Yeah, it used to be Azure AAD. For
Azure
those who
AD.
know
Yeah, yeah. I mean, sometimes I can't keep up with all the naming, but it
that.
is Microsoft Entra ID now, formerly Azure AD. And that's going to be a huge component into like securing your workloads on Azure, right? And then we have things like AI services and OpenAI, right? OpenAI is actually available on Azure Service or Azure Services, right? But the most important thing about AKS, and it's really critical, is that it's actually CNCF certified to be Kubernetes conformant, right? What that means is that all of the open source tooling that's available within the Kubernetes ecosystem today, like Kata, Dapper, Istio Service Mesh, things like that, you can actually install those into your AKS clusters today on your own using whatever open source installer package is out there, whether it be Helm chart or just applying a YAML manifest. But the
So you
real
basically
value
get the best of both worlds, right?
was that.
You get the managed service, you get the best of both worlds. You get the
Yeah,
managed
yeah,
service,
yeah. And
you
that's
get all the enterprise scale features
yeah.
installed for you, but you also still get to have the cloud native experience, right?
Right, right, right. And I think that's the beauty of it, I always that a lot of these very, very popular open source projects are actually available as an add-on. And what does that mean for you? Well, it means that it's supported and it's all managed by the AKS team, which is pretty awesome. So, bottom line is that the AKS platform will give you a complete end-to-end cloud native development experience, right? It'll give you a comprehensive platform for running your applications, operating them at scale, securing them, and being more effective with Kubernetes. So Let's switch gears just a little bit. We talked a little bit about taking a microservices approach when adopting our AI strategies. But let's talk about the app in general that we're going to be working with today. Okay. So we have a brand new AKS demo app that we just released. I think it was a few months ago.
Yeah, it was a
Maybe.
few months ago.
Yeah.
Maybe even
Um,
3 months. Yeah.
yeah, I think, yeah, time flies. So,
When you're having
um,
fun, right?
yeah. So, what this new sample app is, it is a fictitious pet supply store, and it's built using many microservices. So, it follows the whole cloud native development practices and patterns. And it's a pet supply store. There's two components to the pet supply store. One is the front end where users can actually add items to their shopping cart and submit orders. But the part that we're going to be focusing on today is the back end capabilities, right? So there's a product management capabilities that's within what we calling the admin portal. And this is where employees would go and manage the product catalog and add new products. But the thing that we want to do here is we want to enhance the user experience for our employees. And we actually want to generate these product descriptions, reduce a little bit of that cognitive load in trying to be creative and create and and write a description from scratch. We actually want to ask OpenAI for this product description using the product name and the product keywords. Okay. So here, um, again, we have the backend portal and it works just fine as is.
Just
But
very manual.
yeah, very manual. Like, I don't know, like my creative brain sometimes doesn't work all the time or it doesn't work well all the time. And sometimes I get writer's block in trying to figure this stuff out.
Exactly.
So why not lean on OpenAI for this? Okay. Now, let's go through a very, very high level application architecture and show you what this sample app is consisting of. And so it all starts with the customers, like I mentioned. The customers will actually navigate or browse to the storefront application and they'll be able to see the product catalog. That product catalog is actually gathering data or retrieving data from a product service. And when they add the items to their shopping cart and click the checkout button, the checkout's nothing fancy. It just submits an order to a order microservice. That order service then pushes the order into our queue. In this case, we're using RabbitMQ. That's pretty much it from the front end perspective or from the customer perspective. From the employee perspective, what we have is we have a backend that we call the store admin. It also needs to retrieve product information. So it calls the product service as well. But we also need to process orders that come in through the queue. And so we have this microservice called the makeline service, which retrieves orders from the RabbitMQ and puts that order into a Mongo database. Now, you might be wondering why RabbitMQ, why Mongo? Obviously, we could use Azure services, but for simplicity, we chose just to deploy this all into a container. And so these are essentially all containerized solutions, all written in various programming languages, and all deployed onto our AKS cluster. Or I guess we will deploy it onto our AKS cluster. But in production, obviously you should be working with more managed solutions. And so you can easily swap out this RabbitMQ with, say, an Azure Service Bus, or swap out this MongoDB with, say, Azure Cosmos DB. No problem. Okay. So this is kind of like our solution that we have today. And just a quick shout out to the Microsoft Global Black Belt team. This solution was actually inspired by a solution that they wrote, a sample app that they wrote called Red Dog several years ago. Okay. So we just kind of took that concept and applied it here. So this is what it is today, right? And remember in the previous screen, IO, we wanted that Ask AI button to kind of help us with
Yeah,
that. So what do? We
we added
bolted on
AI to
AI, right? So
It's
all we do,
amazing how easy it was to do that with a platform like Kubernetes.
yeah,
Paul talked about microservices earlier, and all we had
mhm,
to do was bolt on that additional service, and it automatically enabled that feature.
yeah. And so we literally just created a brand new microservice, and we called it the AI service. We're not really good at naming things. Maybe we should have used ChatGPT to help us name our projects, but yeah, we have a brand new microservice written in Python, and it talks to Azure OpenAI using the chat completion endpoint. Now, there was a little bit of stuff that you had to do with this AI service, right, IO? Like you can just talk to Azure OpenAI using the REST endpoints, but um, that's generally, probably not the best way to do it. The best way to do it is to use some sort of library, and so I think you use the library for this, right, IO?
Yeah. I use this library called Semantic Kernel, and it's a game changer when it comes to prompt engineering. I'm sure most people here have heard about prompt engineering.
Yeah. What?
It's all
So like,
about.
that's the thing that I hear. So, Chat Chat GPT,
Mhm.
co-pilots, and then prompt engineering. What's prompt engineering? Is this a whole different programming skill that I'm going to have to learn, or what's up with that?
Honestly, I'm just gonna keep it simple. The
Yeah.
mostly like the easiest way I can just describe it. It's just the process of instead of writing code to get the application to do something,
Mm-hmm.
you basically make sure that you're writing natural language. But you have to write it in a way to make sure that the AI actually does exactly what you want,
Mm,
right? So you don't want it to do something out of scope of your product. You want to make
mm,
sure that think about things like security, making sure that it doesn't do anything unexpected or anything unethical, right? So there's a lot of things that comes into prompt engineering, not just writing the right query or the right words. And that is actually one of the beauty of semantic kernel is it actually makes a lot of that so much easier.
mm. So you're setting guardrails essentially, right? Like boundaries in what it can answer. You're not just sending a question, just a random question with no context, right?
Exactly,
Ah,
exactly. So it
okay.
actually has a lot of and it takes care of a lot of that plumbing, a lot of that guardrails, a lot of that grounding. It takes care of that for you. Actually, this might actually be a good time to go a little bit deeper into it.
Oh, okay. Cool.
Okay, so we talked about semantic kernel. We talked about prompt engineering. How do all these fit together, right? How do you actually tack on these AI capabilities into your application? There's a lot of ways you can do it. You can write it directly. You can interface directly with the OpenAI SDK, or you can actually send REST, request to the OpenAPI endpoint. But we actually wanted to do it because we're programmers. We like to be efficient, right? We like to build on top on the shoulder of giants, right? So why
Yeah.
would we do all that ourselves if there's a much easier way to do it? So what is semantic kernel? Basically, it's open source.
Hmm.
Introduced by Microsoft, similar to LangChain. For those who have probably heard about it, but this is designed from the ground up to be enterprise ready to make it
Cool.
super secure. But it is open source, so you can definitely check it out. Definitely contribute if you want to. It does support multiple programming languages, so it supports .NET, Python. Now there's Java as well. I believe
Mm.
there's a JavaScript coming up in addition to that. So
Oh,
those are
nice.
really great features.
Yeah.
But what is it about? What makes it so much easier? Well, think about the process of building a chatbot with OpenAI, for example, right? There's a lot of things you can do. right? But you want to make sure that the chatbot has the context of what you're talking about, right? That doesn't happen automatically. There's a lot of work that actually goes into doing that. But semantic kernel makes it a lot easier by adding the concept of memories and models, right?
Yeah.
So when I say memory, just think about, say you're building a regular application. You need to make sure that the application has the context of what you're talking about, right? If you're making calculations, you need to know what to add, what are the different numbers to add, what are the different processes or things that it has in its memory, right? Well, AI chatbots also need to do that. So when you're building a chatbot, you want to give it the context of the previous things you've already talked about in that conversation so that you
Yeah.
can more accurately predict what to respond based on the entire stream of your conversation. But here's the
Mm.
challenge. Did you have a question, Paul?
No, no, I'm just like things are turning in my head like, oh, so this is how you can prevent these models from kind of going off the rails.
Absolutely, absolutely. So when you think about it, so how do you make sure that it continues to have that memory, it continues to have that grounded context? How do you do that? Well, you can do it manually again. There's a lot of different ways you can do it. But semantic kernel, because we're lazy, right, makes it so much easier, right? So when you think about, for example, when say you're having a very long conversation with a chatbot,
Hmm.
well, I'm sure most people here probably understand the concept of tokens. Basically, token is the number of units of input you can provide to
Hmm.
the AI interface in order to get your response. But the problem is, if you're having a long conversation with the AI, well, guess what? Your tokens just exploded, right? You can have thousands and thousands of characters, thousands of tokens. So
Wait,
how
wait,
do
wait,
you
wait.
keep that?
Wait, what's a token? Is a token so it measures based on the inputs that I send to the model, but is a token a character? Is it a sentence? Is it a
Yeah,
word?
that's a good question. So a token could be a character. It could be like a word,
Hmm.
right? So the chatbot, it could be like the AI system basically needs to take all those little. So say for example, it's a word, right? So the AI
Hmm.
system has to take those words and put them together. So each word could be a token, and there's a limit on how many tokens you can put into the AI model, right? Because it's not
Mm.
it's not unlimited, right? So for example, I think GPT-3 had a certain number, GPT-4 extended that number, but it's not unlimited, right? So
Got
say
it.
you're having a really long conversation with the chatbot, right? How do you make sure that you don't run out of token limit? But also, how do you make sure you save on your cost? Because the more tokens you use, the more expensive it is, right? So say, for example, you're sending 8,000 tokens, well, that's going to
Hmm.
be a lot more expensive, 8 times more expensive than if you're sending 1,000 tokens. So you have
Mm.
a long conversation, you've had a bunch of back and forth with the chatbot. How do you make sure that you're not going over that limit, but also not wasting money? Well, semantic kernel actually has the process already inbuilt into it to convert those words, so tokens in the form of words,
Hmm.
into what we call like embeddings that makes it so much smaller, right? So
Ah.
just think about turning words into numbers. Do you have a question?
These words or numbers are kind of like converting the words into numbers is like the computer's way of
Understanding,
identifying. Yeah,
understanding what you're trying to say.
I see. I see. Okay, cool. I'm wondering if anybody out there in the live stream has dealt with some of this stuff yet.
Yeah, any questions?
If you have any questions, feel free to throw them in the chat. We'll be able to answer them there in live and potentially even bubble up stuff. But like this seems like a whole new realm of things that we need to understand as developers. And so it seems like semantic kernel, the SDK actually packages that up for us and just makes things just a little bit easier then.
Absolutely. Yeah. So if you
Yeah.
were a prompt engineer, you would have to think about tokens. You would have to
Hmm.
think about things like embedding, right? So converting
Yeah.
those words into numbers that basically represent this, have the same semantic meaning as the
Yeah.
word that you're using, right? But guess what? With semantic kernel, you don't have even have to think about that. The first
Right.
time when I actually wrote this AI service, I
Hmm.
didn't even know about the embedding conversion that happens in the backend. So that's how
Mm.
seamless it is. You don't even have to think about it. All you have to do is put your words. Semantic kernel takes care of converting it into embeddings and then sending it to the AI service to get your
Nice.
response.
Io, do you want to like just share just a little bit of that code with some of our audience here and just kind of show them what it kind of takes to build something like that?
Absolutely. Yeah, let's take a look at the code actually.
Cool. And let's see, how's that? Put in the chat window if the thing is too small. It looks kind of too small to me, so you might have to bump it up just a little bit. Your Zoom.
All right. How is that better?
Just a few more, maybe like two more.
Okay, let's
That
see.
looks good. Yeah, right there. There we go.
All right, awesome. So this is basically what the store app application code looks like.
Hmm.
Within that, we have multiple services. So in this case, we're going to focus on the AI
Mono
service.
repo, right?
Yeah, we're going to focus on the AI service because, well, we all know that that's the interesting service out
Yeah.
here. So semantic kernel actually makes it so much easier to connect to your actual, Azure identity. You can import all of the packages required and things like that.
Hmm.
We're actually storing the things like the API key into environment variables. So all we have to do is pull it using the OS package for Python.
Hmm.
And then here's actually one of the interesting things, right? So semantic kernel works the exact same way if you're using OpenAI directly. So, or you're using Azure OpenAI. So we all know about OpenAI. You can actually log into OpenAI and actually create your own, get your API key and things like that. Or you can
Hmm.
actually use Azure OpenAI. So this application actually uses both, and it actually gives you the option to choose between them. So in this case, we're using use Azure OpenAI, for example, right? And then basically it initializes the semantic kernel using either one of them. So if you're using OpenAI or you're using Azure OpenAI.
Yeah.
Okay, so semantic kernel has this concept of skills, right? I believe now it's been called plugins. Pretty much the same thing. So when we think about skills, what is a skill, right? A skill is something that you're able to do. Say
Hmm.
you're able to play soccer or you're able to run. That could be a skill, right? So the
Yeah.
same way, the AI service actually has skills as well. It has the concept of
Mm.
skills. So you can actually create your own skills. But here's actually what makes one of the things that makes semantic kernel interesting is that you can you can actually use existing skills that other people have used, right? So all you have to do is copy or download those skills from the internet. So you can
Hmm.
have a skill, for example, that allows you to make a Bing search, right? So that way you can actually make your AI service have access to the internet, for example, right? So
Mm.
there's a lot of different skills. But for today, we're very simple people. We have a very simple skill, and that skill is basically called description generator. So, oh, sorry, it's actually called description, right? So the skill is called description, and all it does is enables the AI service to generate a description based on some input that you provided. Well, what are those inputs? Well, just so you know, for this demo, we're using the Fast API.
Yeah.
So I'm just going to add the router here, and that is actually what we're going to use to provide access to that skill.
Got
So
it.
what are those parameters, the inputs that you need? Well, we need the product name, which Paul actually
Hmm.
showed at the beginning of this demo. You have to
Yeah.
provide the product name, and you have to put some kind
Mhm.
of tags that gives description about the product, right? Just to help the AI have a more accurate description generated for you. So you can see here, you initialize the class, you get the product, and you're able to provide the name as well as the tags, which is a list of descriptions. And then all you have to do basically is to make sure that it comes as a list, right? So you want to join them basically as a single sentence. And then you want to make sure that you're setting the context, right? So again, semantic kernel makes it so much easier. You create the
Yeah.
context, and this is actually where that prompt engineering thing I talked about
Yeah. Yeah.
earlier.
Yeah. So
This is where,
I'm I'm like
yeah,
I'm like peeking at your file explorer, IO, and it looks like the skills. I see a skills directory and then a products. It
yeah,
looks like a product skill directory there. And then
Mhm.
I see a SK prompt. Is that where you're storing the prompt for the prompt engineering?
Exactly, exactly. So you're gonna see
Ah,
that in my code, I don't actually have any prompt. I'm gonna get into that in a
uh-huh.
second, but there's
Okay.
actually no prompt in my code. That's all being handled by the skill, which is actually pretty cool, right? So say for example, this is a chatbot, which would be more advanced than this. All you have to do
Yeah.
is continue to put the the what you your conversation with that chatbot. You continue to update this context with that conversation, right? And as you continue to update it, it automatically continues to turn it into embeddings and
Mm-hmm.
continues to send it to the AI service and gets a response based on the context. So grounding is very, very important in prompt engineering, and semantic kernel makes it so much easier to do that. So we're gonna
Cool.
set the context with the name as well as the tags, and
Uh-huh.
then we send it to the function. Basically, you get the results and you return it to the application, and that's it. So you can see here no prompt at all
Yeah.
in this code. All you have to do is import the skill and you're done. So how does that work? Basically, you have to set up your configuration. So this is the skill, the product skill, this description ability of the product skill. And
Mm-hmm.
here you have the configuration. So you can set things like temperature. If you want it to be more creative, you might want to increase that number. You want to
Mm-hmm.
have the maximum tokens of 1,000, right? This is actually one of the ways you can make sure that you're not going over your cost.
Yeah.
But think about, I'm going to show you what the prompt looks like, but it's a lot. It's quite a lot of text, and with 1,000, that's not a lot. And that is actually where the beauty of semantic kernel comes in, because it actually takes all that text that I'm about to show you and turns it into a much smaller summary of it that would actually be a lot less than 1,000 tokens. So within the configuration, you have to set up your parameters, which is the name, right? So no default value in this case, but if you want, you can add one, as well as the tags. So what does the prompt look like? Well, check this out, guys. So basically, you can actually have some grounding rules at the very top of it, right? So things like don't waste words. Obviously, we don't want to spend any more tokens than we have to, right? You want
Yeah.
to have things like short answers, no racism, no profanity. You put stuff like this, and that actually makes it grounded, and you don't actually have to worry about it anymore. You put this at the top as a default, and that's it, right? So this is actually where you put the name of your product. Um, so basically, you want to say things like, "Don't say this, whatever it is." Just as
Mm-hmm.
this is just
Hmm.
as an example, right?
Right.
Um, you can also do things. So this is basically the end of that list, and then this is where the prompt starts, right? So the prompt basically is me telling the AI system, describe the following products sold in a pet supply store, right? So it's going to know that this is a pet supply store, and I'm going to get the name of the product. So this is an example of a product, right? And then here's the name of the tags, and here's an example response that you're expecting, right? So when it comes to prompt engineering, a lot of the time you want to give it an example so that it actually learns and it actually knows the context of or what kind of format you're expecting your answers to be in, right? So I'm giving you a few examples here, so you can see here's a few examples here, and then I'm going to ask you the actual question, right? Describe the following product again, give it the product name as well as the tags, and then it is going to give me the description, and that's it. That's all you have to do to create a skill.
That's that's awesome. And to have this like committed into your repo and and go through the normal processes as that we do as developers with the PR workflows and all that stuff. That's good because then you have a second pair of eyes kind of checking the prompts and whatnot. So cool,
Absolutely.
cool, cool, cool. Um, let's say this. Why don't we go see all this stuff in action?
Yeah, let's
Yeah.
deploy. Let's deploy some stuff.
Okay, cool. So I just brought up on my screen here what the application actually looks like, right? So this is the front end that I talked about. Um, this is where users can add things to their shopping cart, and they can actually check out. And remember, I said this is like super simple. All you do is check out, and there's no order information. We don't collect PII or anything like that. We just send it over, right? We just want to demonstrate how the microservices all interact with each other. There's also the back end. Let's see. Pull this up. And this is what we're going to be doing here is we want to add the AI capabilities here. Okay. So what we'll do is we're going to build all this from scratch. So what we're going to do is just go to your web browser. You can actually scan that QR code from the beginning, or there might be a short link. But what you can also do is you can actually use search. So you can search for OpenAI and AKS, and I'm using Bing search. You can also, use that other search product if you like, but it should be the first link at the top of the search results. And it should say something like deploy an application that uses Azure OpenAI. Okay. And so we'll just be working through this doc here. Okay. Now, what you need here to get started is number one, you need an Azure subscription. Okay. So if you don't have an Azure subscription now, unfortunately, you'll have to go click this link here, and I will bump up the resolution to make it a little bit bigger. You'll have to click this link here and just go create an Azure account, and there is the ability to create one for free. Now, just having an Azure account is probably not going to be enough, especially if you are looking to use Azure OpenAI models for this example. And so once you have your Azure subscription, you'll need to click this link over here, request access to Azure OpenAI. So if you click that link, and I'll just open a new tab just to kind of show you what it looks like, it's basically a responsible AI checker just to make sure that your intent to use the models is all good. And you're basically going to request whitelisting for this particular service. Okay, so that's kind of the flow right now. But let's say you have all that, and let's say you just want to start working with this and seeing it in action, right? So this tutorial here has all the instructions that you need to get started and deploy this particular solution that I just displayed, right? So what you need to do is, and if you have a terminal and if you have Azure CLI already connected, that's great. Log in and you can run these commands. But did you know that, and this is actually news to me just a few months ago, there is this open Cloud Shell thing button that you can literally click and it will open a Cloud Shell right here in your web browser. Now, let's see if I can go ahead and log in. What this is doing here is it's actually logging into my Azure account, and it's going to fire up a Cloud Shell for me. If you're not familiar with what Cloud Shell is, it's basically a shell or a terminal all running within the Azure portal in the Azure cloud. So there's nothing local here. Okay. So like I said, I don't have anything. Let's see, what do I have? I don't have it in my subscription. So then let's go ahead and create this resource group. Okay. And so I literally just hit this, I hit this copy button, and it copied the text that's in this text box. And then I just pasted it over into my shell over here. So my resource group is created. The next thing I need to do is create an AKS cluster. So this is the command that you need to create that AKS cluster. I'll simply copy it one more time, and then I'll paste it into my terminal and give it a few minutes. It's gotten a little bit quicker in terms of creating AKS clusters. So this should take roughly around 5 minutes, 5 to 7 minutes. So we'll let that bake. Okay. And what I'll do is I will open my Azure portal. And what I'll do is let's look for my resource group. Boom, boom, boom. Okay, so my AKS cluster is being created right now. What I'll do is I'll search for OpenAI in the Azure portal. Okay. And it'll be that first one in the list here, Azure OpenAI. So I'll go ahead and click that. And I'll click this create button to go through the wizard of creating this OpenAI service. Okay. Let's see. Resource group. I need to select the resource group. So it'll be my resource group. That's kind of what I called it. And I need to pick a region. So OpenAI is available in select regions. So I would recommend that you go out to there's a website that shows all the products and services by region. But this region picker is pretty accurate. So I'll just pick a region. I know my AKS cluster is in the East region, but I'll just pick Sweden Central for now. Yeah. And I'll give it a name. Naming things is hard. IO. Give me a name.
How about you use the description generator? I'm just joking. Let's just call it AI AKS dash AI service.
Yeah, it's like, okay. All right. That should work. Now they need to be globally unique, right? So I'm
Oh
actually
yeah.
surprised.
Maybe put like
Um,
a dash U there.
yeah, you know what? Let me put my initials just to be safe. Okay. Pricing tier, I guess you only have one option, so we'll go ahead and click through that. And we want to be able to access it over all networks. Um, I'm not going to use tags for now, but tagging is a good practice. And we will hit create. Okay. Um, how long does this usually take? Do you remember, IO?
Honestly, it seems to be getting faster and faster these days, so
Yeah.
I'm not sure. It should only take a few seconds.
Okay.
A couple of minutes. I mean,
Cool, cool, cool. So we'll sit on that, and we can see that our AKS cluster is still provisioning. So we'll just let these things bake a little bit. Yeah, and yeah, we're nothing like a live demo, right?
oh yeah, waiting for deployments. That's always the best part of the demo. It's like, oh, I
Yeah,
hope it doesn't fail.
yeah. We just sit and twiddle our thumbs, So, but this should be relatively quick. I've seen this create in about 2 minutes or so. So we'll see. We'll see how this goes.
Yeah.
Hey, look at that. It is done. Okay.
I mean, isn't
Sweet.
it just amazing the power of the cloud these days? Like, you can have the power of the world in your fingertips in a few seconds.
Right,
I
right.
mean,
And I am all over the world. Look, I'm in East US for my AKS cluster and Sweden Central for my OpenAI. I should have just put it on the one location, but
yeah, it's
yeah.
crazy. You just imagine, like, back in the day, imagine having to build your own LLM and
Hmm.
host it somewhere, have some server
Yeah.
and all that. What a world
Yeah.
we live in right now.
What a time to be alive. That's right. Okay, so looked like my AKS cluster is still provisioning. What I'll do is I'll just go into my Azure OpenAI account, and I need to deploy a model, right? Because just having the account um, is good, but there's all sorts of different models that you can actually take advantage of, and so we'll need to deploy a specific model. Okay, and so I'm in the Azure OpenAI blade in the Azure portal, and I'll need to click on this model deployment. And you can see here, there's a button that says manage deployments. Okay. You can click that, but it'll take you right over into the Azure AI Studio. What I like to do is I like to just right click that and open this in a new tab because I like to come back and forth between the AI Studio and the portal. So we'll open this portal and I'll have to authenticate again. There we go. We are in the Azure AI Studio. There's a lot of different things that you can do here. I would suggest that you browse through this whenever you have time. There's actually a chat playground, so you can actually play with these models before you even develop your app, which is cool.
You
But
can
what
test
I'll do,
out prompts and stuff like that as well.
say that again.
Oh, you can test out prompts as well.
Oh yeah, yeah, exactly. You can test your prompts before they actually get committed into code. So that's a good point. Okay. What I'll do is I'll actually create the new deployment, and I will select GPT 3.5 Turbo. Okay. When you select the model, you have to name the model because technically you can have a few deployments of your model, right? But you do have to give it a name. And so uh, I'm not that creative. I'm just going to give it the same name. Okay. So I'll go ahead and give it the same name, and I'll hit create. And this is like super fast. There we go. It's done. Okay. So we have pretty much everything that we need. Let's go check what's going on with the AKS cluster. Sweet, it's here. Okay, cool. So I have the AKS cluster. I have an OpenAI account with my GPT-3.5 model deployed. I can go ahead and proceed to deploy the rest of this stuff. Okay. So the first thing I need to do is connect to the cluster. And you can connect to the cluster, and you can also install the tools to interact with the cluster using Azure CLI. Okay. So if you run this command, if you don't already have kubectl, kubectl is what I call it. It's also kubectl. There's a whole bunch of other pronunciations, all valid. But if you need that CLI, you can install that. I already have it. Actually, Cloud
The
Shell
Cloud Shell
already.
has it. The
Yeah.
Cloud Shell has it already, right?
Yep. It's all here. So I don't need to install it. But if you're working in your own terminal, then obviously you need that. Okay, so I'll go ahead and copy the AKS get credentials command. And what that will
But
do is it'll allow me to connect.
that's one
So,
of the beauties of AKS, right? It makes it so much easier to keep your cluster, API server secure with your
mhm.
credentials, and you don't even have to think about it. It just automatically does that for you, as long as you assign it, give yourself permission in the portal. It actually makes it so much easier.
Yeah, absolutely.
Security by
So,
default, right?
yeah, secure by default, exactly. So I just ran the kubectl get nodes command, and you can see that I have 1, 2, 3 nodes ready to go. Okay. So what we'll do is remember this diagram here. So what we're going to do is we're actually going to deploy just that top half. Actually, it's not even half, the top part. And
Yeah.
then we're going to deploy this in just a few minutes. So what we'll do is grab this command, which is the kubectl apply command, and we're going to apply a manifest that'll deploy that entire top half for us. So let's see. I'll just clear my screen and deploy this all in one YAML, and you can see that there's a bunch of stuff going in. So we have MongoDB, RabbitMQ, the order service, the makeline service, the product service, all that fun stuff, right? And eventually, we'll get that all the pods up and running. Okay. The next part, deploy OpenAI. We've already done this, so we can actually move ahead. One key thing to note is we need to grab the Azure OpenAI keys. We haven't done that yet, but we'll go ahead and do that in a second. Okay. Now, with the deployment, actually, you know what? Let's go check our deployment. kubectl get pods.
Oh, success.
Yeah, I like that. This has been bugging me. Restarts, but you know what? That's the power of Kubernetes, right? If a container
Exactly.
crashes, Kubernetes will bring it right back up for you. So it's doing its job. Now let's go browse to this thing. I need to get the IP at service. Store admin is where I want to be, right?
Yeah.
Okay, so let me go ahead and copy that public IP for store admin. And
Let's add some products to our catalog.
yeah, let's see. Loading eventually.
At some point.
There we go.
There
Okay.
we go. Awesome.
All right. So let me bump up the resolution here. So let's go to our products. These are the default products and no AI button, right? Uh,
I guess you're gonna have to do the work yourself, Paul.
we're gonna have to do
Yeah.
the work. Yeah. Like I don't know what to put here. I can put Scooby Snack, 299.
Very precise
I'm all
price
out of
there.
ideas. You know what? Let's just go ahead and deploy that the AI service and have it do the work for us. Now, here's a cool thing. IO did mention that you can use either Azure OpenAI or OpenAI directly with that AI service, that AI microservice. And so there's directions for both here. So if you're using Azure OpenAI, follow this manifest. If you're working with OpenAI, then click that tab and you can go through that. But we're using Azure OpenAI here, and so what we'll do is we will copy this manifest because there's a few things we need to do here. Okay, it's missing a deployment name, it's missing an endpoint, and it's also missing the API key. So we're gonna have to um, fill that stuff in. Okay, so let's see. Hopefully, I don't have. Let's just. If I had a copy, okay, I don't have a copy. That's good. So what I'll do is, did you know IO in Cloud Shell, there's a very very lightweight code editor.
Yeah, it's really cool.
Yeah.
It makes it
So
so much easier, like not having to use like Vim or anything like that, right?
yeah, I
It's
mean,
like
we,
VS Code.
we can use Vim, but we can also use this lightweight code editor. So you can literally, you know what? Let me create the file first. I think you can
You
create it
can
all
create it
on the fly.
directly.
Oh
You can
yeah.
write code and then yep.
Okay, let's do that. So code, remember that's the executable for VS Code. So I can do code, and I need to call it AI service. So we'll
Hmm.
go ahead and do that. And what did I do? I copied and there's no paste.
Oh, just Control V, I guess.
Yeah.
Command V.
Okay, cool. So now I have, what do I have here? I have a deployment and I have a service. Okay, cool. I do need to plug in my information. So I do know my deployment name. So GPT 3.5 Turbo. Um,
By the way, for
what was
those who
it?
don't know what deployments are, they're basically that is how you deploy the server on the Kubernetes server.
Mm-hmm.
And basically, it creates the pod for you, but also it makes it so that if your pod crashes or your container crashes, it automatically restarts. Right? That's Kubernetes doing its job.
Yeah, yeah. And so I need just a few bits of information. I need the endpoint and the API key. So what I'll do is I'll actually go back to my Azure portal, go to the Azure OpenAI service, and come down here under resource management to keys and endpoints. Okay. Um, Here we have keys up here, which I can easily copy to my clipboard. And then we also have endpoints over here. So there's endpoints for language APIs, Dolly APIs, Whisper. In this case, we're using language APIs. So we'll need to copy that to the clipboard. And I can come here to my code editor and I can paste that in. And I'll also need the key. And we'll paste that in here. Okay. And I will save. There's a secret button over here. It's always funny about this. There's a if you click in this region,
I never knew of that button.
yeah. There used to be an ellipses over there, but
Oh,
it's not there anymore.
right.
But it used to be there, and that's the only reason why I know that it's there. And so I can save it and close the editor. And I
Control
know
F.
I just shared my keys to the world, but that's okay because I'm gonna delete this whole thing as soon as we're done with the live stream.
Security is
So
important.
what we'll do here is now that we have our manifest created for the AI service, I can copy this command and I can apply it to my cluster, right? Because we're using the manifest to tell Kubernetes that, hey, we have a brand new deployment. And so we're going to deploy the AI service, which was that bottom section of the diagram that I showed. Okay. And you can see here that my AI service is created. Actually, the deployment and the service has been created for the AI service. So we'll clear that. And let's go see how it's doing. Okay, look at that. AI service is running and it's been up for 21 seconds. Let's check the logs on the AI service. So kubectl logs, I can use a selector and I know my app is called AI service. There. It is up and running. Sweet. Okay.
Awesome.
Now,
Do we want to talk a little bit about what a service is for people who might not know? So we talked about the pod, we talked about deployment.
mhm,
So the service is basically what gets you access to that server, the pod. So by deploying the service, it actually automatically creates, in this case, this is a load balancer service type, right?
mhm, yeah.
Yeah. So if you're using the load balancer service type, then it automatically generates an Azure load balancer for you,
Mhm.
gives it an IP address that you can then use on your browser.
Absolutely. Yeah. And there's different ways and the reason why we said it was a load balancer is if we scroll up here, actually
So this is using the cluster API, sorry,
well
cluster
the
IP.
AI service, okay, so there's
Yeah,
two different well actually there's
the-
four types of services that you can deploy. And for the AI service itself, it's cluster IP, meaning only pods inside the cluster can access that particular service, which is what we want. We don't
yeah,
want to expose our AI service to the public and have a publicly accessible endpoint that anybody can just kind of call and reach into. No, we want to come in through the store
browser.
admin site. We only want to expose the store admin, and the store admin actually talks to the AI service. So
Exactly.
it's working exactly the way we want it, and you can actually see the various service types. If I just clear my screen, kubectl get service. You can see here that the majority of these services are using cluster IP, and the only two that are using load balancer are the applications that we want to expose to users, whether that be customers or employees. So, okay. So now that, I mean, since I'm here, I might as well just grab that IP and test this out again because we are pretty much done with the deployment, and that's all it took. I mean, IO did all the heavy lifting of writing that AI service in Python and using the semantic kernel SDK to interact with OpenAI models. And that semantic kernel SDK actually works with either Azure OpenAI or OpenAI. And from what I'm hearing, it'll be able to interact with pretty much um, a lot of the other AI models as well.
Yeah,
So
yeah.
it's a pretty cool entry point, pretty cool SDK to use within your applications.
And it
So
automatically turns you into a prompt engineer without having to study or learn advanced skills, right?
yeah, yeah. Okay, so hey, look at that. We have orders coming in. We have customers on our site. Um,
Nice.
let's go ahead and test this out. So I want to add a product, and I'm gonna add a product, and I will call this a dog's best friend. And this will be a dog chew toy. How much should we price this at, IO?
2850.
28.50. Got it. Okay. So, a dog's best friend. It's a dog chew toy. And hey, look at that. We have this Ask OpenAI button. Okay. And there's some code. I forgot. I didn't show it to you, but there is some code in the store admin site that is aware of the AI service, right? And so within the store admin site, it detects like if the AI service is available, let's show the button. If the AI service is not available, then this button doesn't show, right? So we can programmatically enhance the user experience just based on whether or not services are available, right? So that's just another strategy that you may have to think of as you start to bolt on these intelligent capabilities into your existing applications. Okay.
Yeah, that's the
So
power of Kubernetes and microservices, right? Both
yeah.
on components.
Yep. So here we go. Moment of truth. Let's ask
Kind of
OpenAI.
fast. Yeah,
Hey, let's
that took
see.
less than a second.
Yeah, that was pretty fast. Okay. Make your pup's tail wag with the joy. Hey, I like that. Okay.
That is so cute. So
Yeah.
cute.
Okay. Cool. I like that. I'm gonna save it. And so let's just go ahead and save that product. And it's available now. It's available for sale. Now, if I were to log into the front end, I'll copy that IP for the front end. And we will browse to the front end site. And if I scroll to the bottom, a dog's best friend. Oh, I love it.
There you
And it
go.
is 28.50, just as you stated. So let me go ahead and order one of them. Actually, you know what? I have 3 dogs. I'm gonna need more. Uh let's bump this up. Let's add 2 more. So now I have 3 for all 3 of my puppies. Okay, boom.
There you go. We just ordered some toys without having to pay for it.
And I didn't put shipping information too, so I don't know where that order's gonna go. Hopefully, it gets to my house. um, that's pretty much it for this first episode of our 4-part series in working and building with building intelligent apps using AKS. So what do we learn here? Well, we learned a few things. Number one, we learned how awesome semantic kernel can be in helping us to build that prompt engineering muscle and committing that stuff into our repos, our projects, right? So that was pretty cool. The other important thing that we learned here is as you are adopting your AI strategy for your organization, we recommend that you do take a cloud native approach to it all. And if you're not using microservices today, that's no problem. I mean, you can always ease your way into cloud native just by creating a microservice and bolting that one thing on to your existing applications, right? That shouldn't be a problem. The one thing that we saw here was we saw the power of Kubernetes in number one, how it's able to orchestrate all of our containers for us, make sure that they're all up and running. Remember, we saw that virtual, I think it was a virtual worker, it was crashing, but Kubernetes restarted it for us a few times. And so Kubernetes and AKS is a excellent choice. It's an enterprise ready cloud native platform, which should be able to suit your demands, right? And then we got to play around a little bit with Azure OpenAI, deploying models and whatnot. So um, that was pretty cool. Thanks, Io, for sharing us some of your knowledge around semantic kernel and walking us through, how that code works. So that was pretty amazing.
Yeah, and thanks, Paul, for that very clear explanation of how it works. I
Yeah.
hope everyone's excited to get started on their AI application journey. And guess what? Like with all these technologies, you don't have to be a data scientist, right? You just need to be able to, yeah, you just need your creativity to get
Yeah.
started.
That's exactly what it is. You just need your creativity. I love that. So I would say we're pretty much nearing the finish line here. We got our first application up and running, and you may have noticed I plugged in my API key into that YAML manifest, and I deployed it that way.
Bad
Um,
practice.
Not the recommended way to do it. And so what I would suggest is you tune in to next week's episode. Um, a teammate of mine, Josh, and Michael, our moderator, will be leading the next episode. And they'll actually show you how you can secure your access to Azure OpenAI from AKS using workload identity, right? Workload identity is a pretty cool topic. It basically allows you to connect using no passwords, right? So no more API keys. So I would suggest that you tune in for that. And it's been a blast. So thank you, Io, for being on. Thank you, everybody that was on the live stream with us. And thank you to Michael, who's been manning the chat window and answering all your questions. It's been fun. And with that, I would say bye bye, everybody.
Bye, everyone.
Bye bye, Io.